Hello again. In the previous lesson, we introduced things like degrees, radians, coterminal angles, and arc length. In this lesson, we'll begin using the unit circle. The unit circle is one of the most important tools in trigonometry. So let's begin with quick rules. The unit circle has a radius of 1, and the equation for that is x squared plus y squared equals 1. A point on the unit circle has coordinates of cosine theta, sine theta. Cosine theta, cosine theta is the x coordinate, and sine theta is the y coordinate. Changing y, changing x. That's how you got to think of it. Quadrants determine the signs of sine and cosine. Okay. So the main idea is this: on the unit circle, cosine comes first because it is the x coordinate, and sine comes second because it is the y coordinate. That's the big idea, right? Look at some problems. Example number 1: fill in coordinates for common angles of 0, pi over 2, pi, 3 pi over 2, and 2 pi. Then state the sine theta and cosine theta for each. Again, these are common angles. Now, when we're looking at this, we're going to use the unit circle. Every point, or in the unit circle, every point is written as cosine theta, sine theta. Okay, on every point, let's just think of it like if I were to sketch a circle like this, every point you would have, from here to here, it would be, this. Just look at it like this: cosine theta and sine theta, right? So every point has a cosine theta and a sine theta. So you got to think of it. Okay. So we're going to start with 0. So theta equals 0. At 0 radians, the point is on the positive x-axis, right? So theta equals 0. So that point would be 1, 0. Whereas the cosine of 0 is equal to 1, and the sine of 0 equal to 0. Okay. Now let's look at theta equaling pi over 2. Okay. So theta equals pi over 2. Okay. Now, pi over 2, that is 90 degrees. And a you can look up a unit. um it's called a unit circle. And you can look it up, and it'll actually give you all the common angles, like, you know 30 degrees, 45 degrees, 60 degrees, 90 degrees. It's all listed, and it's really good to memorize that table moving forward. That way you know them automatically. So theta is pi over 2. All right. So I'll just put that over here. So when you get to 90 degrees, we're talking about pi over 2, right? So pi over 2 is 90 degrees, and let's go ahead and put that. Remember, 180 degrees is actually pi. So this is pi over 2. So the point is at the top of the unit circle, and then we have 0 equals pi over 2. That point is 0, 1, right? And the cosine of theta, excuse me, pi over 2 is equal to 0, and the sine of pi over 2 is equal to 1, right? And again, notice the cosine, sine. Next, we have pi, or theta equals pi, right? Theta equals pi is going to give me negative 1, 0. whereas the cosine pi is equal to -1, and the sine of pi is equal to 0. Right? Now, theta, let me see. Now, theta is going to be 3 pi over 2. 3 pi over 2 is 270 degrees, right? That's 3 pi over 2, which is 270 degrees. Okay. I said this one was 180 degrees, right? This is 90 degrees. Of course, it's degrees. Okay, so just kind of give you an idea. So 3 pi over 2 is 270 degrees. And so that means you're going from, you're going from here, you're going around, right? And come here. So that's one swoop around 360 degrees. And the point is going to be located at 0, 0, -1. Because remember, numbers down here are going to be negative. So that point is 0, -1. Cosine 3 pi over 2, is 0. And sine 3 pi over 2 to -1. Then from there we have 2 pi, our final one. So our final theta is 2 pi. And the point for 2 pi would be right back here. Right? So that would be one full rotation. So the point back to the x-axis would put us back where? At this point, 0. So that point would be 1, 0. And the cosine of 2 sine, or 2 pi, is equal to 1, and the sine 2 pi equal to 0. Okay. So again, from uh, from 0, we would get 1/0. From pi over 2, we would get 0/1. From pi, we would get -1, 0. 3 pi over 2, 0, -1. Then getting back to the full rotation, it would be 2 pi over, or excuse me, from 2 pi to 1/0. Okay. But again, remember, the x coordinate is cosine, right? And the y coordinate is sine. Okay. So think of it like this right here. 0, 180 degrees, 70 degrees. And at the top, you have 90 degrees. Okay. That's going full rotation. Okay. Then, of course, that's a full circle, 360 degrees. Okay. Again, here, we would have 0. This would be 1. That would be -1. This would be -1. Okay. That's why we have this here, -1, at a -1. All right. Let's continue. Example number 2. Use special angles. Find exact values for the following. Okay. So these are the main special angles in the first quadrant, right? You have pi over 6, pi over 6, pi over 4, pi over 4, pi over 3, pi over 3. And notice the sine and cosine of each. Okay, so first of all, pi over 6 has the point square root of 3 over 2, comma, 1/2. Okay, that is the coordinate of pi over 6. Okay, since the point is cosine theta, sine theta, cosine is the x coordinate and sine is the y coordinate. Okay, so essentially, the find the exact values for this, we would have I'll just write sine for. As a matter of fact, I just remember cosine sine. Okay, theta sine theta. Okay, just remember that in that order. Even though I'll go ahead and write sine on top right here first, since dealing with this was pi over 6. That is 1/2, and then cosine pi over 6 2, right? Okay. And then now let's look at, so we got these two. Now let's look at sine equals, or sine parentheses pi over 4. So we have pi over 4, and pi over 4 on a unit rate circle would be um, square root of 2 over 2, comma, the square root of 2 over 2. Okay. So again, sine and cosine in this case, you can see, are equal, right? So cosine pi over 4, sine pi over 4 are both equal to the, okay? So now we need pi over 3. Okay. Pi over 3 has the point of 1/2 and root 3 over 2. So cosine pi over 3, sine pi over 3, 1/2. This one, okay. Here are the final answers. 1/2 square root of 3 over 2, square root of 2 over 2, square root of 2 over 2, 1/2 3 over the square root of 2, right? And again, you can reference the unit circle, and the unit circle is where I'm getting these values from. State the signs of sine theta, cosine theta in quadrants 1, 2, 3, and 4. Then find the signs at theta equals 5 theta divided by 6, or excuse me, 5 pi divided by 6, and theta equals 7 pi over 4. Okay, this is a pause and try problem, so pause and complete the problem. Okay, so on the unit rate circle, remember cosine is x, sine is y. So in quadrant 1 for Q1, you have x is positive, y is positive as well, right? So in Q1, you have x is positive, y is positive. In Q2, we have x is negative, y is positive. In Q3, we have x is negative, y is negative. And then Q4, we have x is positive, y is negative. Okay. So just keep those things in mind, right? Which means that the cosine would be negative and the sine would be negative as well, because this is cosine, sine, cosine, sine, cosine, sine, cosine, sine. Okay. Just keep that in mind. Now, theta 5 pi over 6, right? Theta equals 5 pi over 6. So this angle is in quadrant number 2, right? quadrant number 2. So the sine is, excuse me, so theta equals 5 pi over 6. The angle is in quadrant number 2. And so 5 pi over 6 is in quadrant number 2. And the sine theta is positive, and the cosine theta is negative. Okay, because remember, you got cosine, sine, cosine, sine. Matter of fact, let me just put that again. Okay, so just kind of give you an idea. We have the sine and cosine of that particular problem. Okay, let's see. Let's see. So now we have theta equals 7 pi over 4. Theta 7 pi over 4. So this angle is in quadrant number 4, right? Which means that in quadrant number 4, we have the cosine being positive and the sine being negative. Okay. Let's continue. Example number 3. Find the reference angle for theta equals 2 pi over 4, etc. Identify the quadrant for each. So these are reference angles, and all we have to do is identify the quadrant. A reference angle is the positive acute angle between the terminal side and the x-axis. So we want to start with 2 pi over 3, and that is in Q2. Okay. All right, that is in quadrant 2. In quadrant 2, the reference angle is pi minus theta. Okay. So essentially, we would look at it like this: pi minus 2 pi over 3. And we have to have common denominator, so we would multiply this by 3. So it'd be 3 pi over 3 minus 2 pi over 3, which equals, simplifies to pi over 3. Okay. So this angle is in quadrant 2, and the reference angle is pi over 3. Okay. Now let's look at 5 pi over 4. 5 pi over, if theta is equal to, okay, so theta in this case is equal to, sorry about the theta symbol, it's not good, 5 pi over 4. So 5 pi over 4. So that quadrant is in Q3. And in quadrant 3, we subtract pi, right? So we're going to do 5 pi over 4 minus pi, which equals, and you have to have common denominators here, so that's 5 pi over 4 minus, and we're going to be multiplying the numerator and the denominator by 4, which simplifies to pi over 4. Okay, so this one is in quadrant 3, and the reference angle is pi over 4. Now we're going to use 11 pi over 6. So theta is 11 pi over 6. Okay, that is going to be in quadrant number 4. And what we do is we're going to actually subtract 2 pi. Okay, so 2 pi minus 11 pi over 6, multiplying this numerator and denominator by 6, we're going to end up with 12 pi over 6 minus 11 pi over 6, which simplifies to pi over 6. Okay, so quadrant number 4 and the reference angle of pi over 6. Now we have negative pi over 3. Theta pi over 3. So a negative angle rotates clockwise. Okay, a negative angle rotates clockwise. So negative pi over 3 would be in quadrant number 4, and the reference angle is the positive angle. Excuse me, the reference angle is the positive angle for the x-axis. So if we have theta equals negative third, the quadrant would be 4, and then the reference angle would be pi over 3. Okay, so just simply that in reverse. Okay, so again, 2 pi over 3 is in quadrant 2. Reference angle is pi over 3. When theta is 5 pi over 4, it's quadrant 3, and the reference angle is pi over 4. And when theta is 11 pi over 6, the quadrant is quadrant 4, and the reference angle is pi over 6. And then in rotation, theta negative pi over 3 is pi over 4, excuse me, is in quadrant number 4, and the reference angle is positive pi over 3. All right, let's continue. Example number 4. We're going to evaluate these exactly, and we're going to use quadrant signs. So we want to start with sine 2 pi over 3. Okay, so 2 pi over 3, and this is a sine angle. All right, and this is in quadrant number 2. Okay, quadrant 2, and the reference angle, as we discovered, was pi over 3. And again, reference for these problems, you can just reference the unit circle. It'll be easier if you're just looking at a unit circle. But I don't have the space to show it here, but you can use it as a reference. The reference angle will be displayed there. Sine is positive in quadrant number 2, okay, because the y would be positive. So therefore, we're talking positive sine 2 pi, or excuse me, pi over 3, because that's the reference angle. Sorry. Okay, so the reference angle would be pi over 3. So the positive sine pi over 3. And we can also write it as sine pi over 3, which equals square root of 3 over 2. Okay, and that's the final answer. The next one, we have cosine 5 pi over 4. That is going to be cosine 5 pi over 4. That is in quadrant 3. Okay, and that reference angle is pi over 4. Okay, bring it back here because I don't want to run out of space. So cosine cosine is negative, right? So negative cosine pi over 4. So we have essentially cosine pi over 4, which equals negative square root of 2 over 2. Because cosine pi over 4 is the square root of 2 over 2. But in this case, it's negative. So it's going to be negative square root of 2 over 2. Okay, we have two more. Hopefully, I don't run out of space over here. I might have to write this a little smaller. So we have sine 11 pi over 6. We discovered that 11 pi over 6 from the previous problem was in quadrant number 4, and that's pi over 6. So this is pi over 6. And then we also discovered that if you're in quadrant number 4, x is positive, or excuse me, cosine is positive, but sine is negative. Okay, so since the sine is negative, we have the sine of pi over 6 is going to be negative. It's going to be negative, and then pi over 6 is 1/2. So the answer is negative 1/2. Then finally, we have cosine of negative pi over 3. Cosine of negative pi over 3. That's going to be in, remember, you're going the opposite direction. So it's going to be negative, right? So cosine of a positive pi over 3 would be 1/2. So this is essentially the opposite of that. Okay. So just keep in mind, since this is negative, you're going in the opposite direction where the positive, excuse me, where the x is going to be positive, and so the outcome is also going to be positive. Okay. But remember, quadrant number 4 is the x is positive and the y is negative. And so in this case, we're looking for a negative times a negative, which is why we have a positive here. Okay. Okay, now let's see. A common mistake is a student says sine theta is the x coordinate and cosine theta is the y coordinate. Correct the statement. Um, so again, the student reversed the coordinates. On the unit circle, a point is always written as cosine theta, sine theta. Okay. Again, that's the x. This is the y. Okay. And again, cosine is the x coordinate, sine is the y coordinate, right? You got to understand that cosine and sine theta, y coordinate. Okay. Just keep that in mind, right? And that's it for that. Now, final review. Okay. I understand this was a lot, but with practice, you will become perfect. Okay. And review those quick rules in this lesson and definitely review the unit circle. And this will become very easy for you to do. All right. Thank you for watching.